Hey,
Hi,
Sheila.
Corine.
Hi, Sheila.
Hello, Hilary. How are you guys doing?
Very well, and you?
I'm
Good, thanks. And you, Sheila?
I'm good, thank you.
हेलो
ठीक है, कहाँ से लेती है चाय?
Good morning, everybody. We are requesting that you kindly mute your video and your sound as well.
बताओ। इसमें रख दो।
Okay. Hey, Hilary, can you try and mute your sound, and Corine as well, and Sheila?
Hello.
Oh, brilliant. That's good. Good morning, everybody. Welcome to this masterclass today. We're requesting that you may kindly mute your sounds, except for our key speakers. Hilary, the masterclass is rather oversubscribed, so we are going to stream live as well on YouTube for our friends who will be unable to join directly onto this. We have about 600 people registered. We expect about half of them will join in person. And so Corine and Hilary, it looks like you guys have quite a big halo effect. So. And ladies and gentlemen, a very good morning to everybody. We will be starting in 3 minutes. You want some music?
Good afternoon, everyone.
And good afternoon.
Yeah, sorry, I came late. So I'm glad that you let me enter to the room.
Good morning, everybody. Thank you so much for joining us today. Hey, Sheila, are you able to? Did you need something, Sheila?
Yeah. Have you let Damaris in? She needs to turn her video on.
Let me just see if. Hey, Damaris, I believe that you're online now. Damaris,
yes, I am.
The video?
Yes.
Excellent.
Hi, everyone. Yes, I'm online right now. I'll be turning my video in a bit. Yeah, thanks.
Excellent, excellent. Ladies and gentlemen, this session is recorded. It's also streaming live on our YouTube channel. We expect a large number of participants, but that's okay, and that's very encouraged. We're very happy that you're able to join with us. The topic we will be discussing today is a very interesting topic and also a very important topic. We are aware that there are many other experts joining with us today in addition to our main speakers. And we are inviting you, therefore, to participate in the chat activity. We're inviting people to send and submit questions via the chat box. And any expert who is in the room to kindly participate in the responses and asking additional questions. These conversations are very important in enriching, as they enrich the discussions we have every day. And we will have a few volunteers in the room to triage some of these questions so that Professor Hilary and Professor Corine can respond to some of them. Thank you to all who have submitted questions to us in advance. We will make sure to include the questions today also for our experts. And as always, I am most happy to welcome my co-host, Dr. Sheila Ogoma, from Clinton Health Access Initiative. And Sheila, please come up and also introduce Damaris.
Thank you, Fred. So I'm Sheila Ogoma, an entomologist, and I work for Clinton Health Access Initiative. I'll introduce Dr. Damaris Matoke, who is one of the directors at PAMCA. She will be co-hosting with us today. Damaris, do you mind turning your video on and introducing yourself? Hello, Damaris.
Because Damaris is still away, I would like to take this opportunity to also announce that our next masterclass is now confirmed. It will take place on the 8th of April, and it will be delivered by Professor Pedro Alonso, who's, as many of you know already, is the director for the WHO Global Malaria Program. He will co-deliver this together with Dr. Patrick Kashur, who is a professor at Columbia University, and Dr. Elizabeth Juma, who works for WHO Afro in Brazzaville. We are warmly welcome for this conversation. It's going to take place, as usual, on Zoom next week on Thursday. So stay tuned for the announcement coming soon. We will be starting in 1 minute. Please bear with us as we admit more people. We have quite a number of people on standby, and we are trying to admit as many as possible. Hopefully we can accommodate all the participants. Because we have people joining us from both the Pacific and the Atlantic, we understand that there are a number of people for whom it's already late evening, but there are also a number of people for whom it's very early in the morning. It's going to be 150 minutes of conversation. You are encouraged to stay throughout, but we understand that because of time differences, some people might want to take a break and return. So this is perfectly okay as well. I'm not sure if Corine is still with us. Oh, brilliant. Corine, I wasn't seeing you. Yes. So, as you can see, we have two great conversationalists today. We have Professor Corine Ngufor, who is from Benin, I believe, and is a world expert on testing and evaluation of malaria vector control products. And we have our insecticide resistance champion, Professor Hilary Ranson, who for many years has actively studied the biology of insecticide resistance and also approaches to control it, to address the issues. We're very happy that they will be talking to us today. We will be beginning the masterclass in about 30 seconds. Sheila, you should play some music first.
I can sing.
Yeah, please go for it. If my son were here, I would sing a little lullaby. So, yeah, could do that. Please use the chat box for any questions you might have, and also any additional engagement you do this. We promised last week that we would provide a PDF copy of the chat. Kindly send me an email if you need that, and I will deliver that to you. Otherwise, the actual conversation itself is on our YouTube channel, but we can also share the audio to those who require it. Okay, so I think we have admitted most of the guys now, and we'll be admitting them as they come in. So, my friends, Hilary, Corine, Shayla, Damaris, the mosquitoes must die. What's happening here? What are we going to do about it? Shayla, you want to take it from there? Get us started.
Yes, yes, thank you, Fred. Please move to the next slide. While Fred is sorting us out, Professor Hilary and Professor Corine, it's a question on everyone's mind at the moment. Can we eliminate malaria with the vector control tools that we have now with Bennett's and IRS, and with the challenges that we have? Can we still eliminate malaria?
So maybe I'll start then. So I think that we kind of have a bit of a race against time, really, with our current tools, because of the problem caused by the mosquitoes rapidly evolving resistance to insecticides and also changing behavior. So I think we definitely need innovation, we need new products, but also we need other approaches that are not solely reliant on products. There are environmental management and other housing and other factors. But I think it is going to be very challenging to eliminate malaria with our existing products alone if they're not accompanied by greatly increased investment in other interventions as well. And by that I mean improving the environment, reducing the breeding sites, and improving housing, etc.
Mm-hmm.
So if I can, yeah, if I can just simply add to that, I think, yeah, I would agree that with the tools that we have at hand, there's not really much prospects to eliminate malaria based only on maybe ITNs and IRS. But if we have much more of a combined approach with all the different measures, environmental management and all kinds of protection measures and outdoor biting control and all of that, then we could be moving closer towards driving it down as much as possible. But elimination, especially in sub-Saharan Africa at the moment, I don't think it's really that close.
If we were to go back to the current wild malaria report that we have, which the latest report that we have, the 2020 report, you see some great signs there, but you also see some pretty bad signs. And one of the things that we picked up was the fact that, you know, the global technical strategy elements that were set up in 2015, we are really diverging from those. We are not making that much progress. is it even a good idea that African countries are talking about malaria elimination in 2020? Shouldn't we just be talking about control?
So, I mean, my personal opinion is I think that the elimination agenda has done some harm in that it has taken a focus off the need in really high burden countries, the need to focus on control and reducing the burden, reducing deaths and morbidity due to malaria. And going back sort of 10 years or so ago, where the focus was much more on shrinking the malaria map, I think we saw a investment and attention sort of focus on those sort of easier to eliminate countries. But we've seen in the last 2 or 3 years that pendulum has swung back again, and with the WHO's high burden, high impact strategy, and going back to recognise that there are some countries where the burden is so high and elimination is such a long way off that we really need to refocus efforts there. So I think, yes, for some parts of Africa and the heartland of malaria transmission, we are very, very long way off elimination. We do really need to be focusing on control, how we can reduce the burden.
Yeah, I've seen a lot of conversation in places such as Nigeria and the Congo with statements such as malaria elimination, and vector control for malaria elimination. Is this a misguided approach? Would you recommend that malaria vector control experts stop using this term in countries such as Nigeria?
Corine, do you want to?
Yeah, I would definitely be kind of worried about the term elimination. I think it's a bit too ambitious, especially in some countries. We need to be able to walk, or before we can think about running or even flying. There are so many countries that still have malaria as a really major public health problem. And to talk about elimination in those countries will be distracting from the focus on trying to make sure if control efforts are really effective. So I think for now, we should really just keep aside the term elimination and talk more about controlling malaria as much as we can with the tools that we have available.
Yeah.
So maybe just to add to that, we've just completed a project in Burkina Faso, where we were looking at mosquito populations, doing clinical surveys to see where the burden of malaria was highest, looking at behavior, use of bed nets, time spent indoors, outdoors, mosquito behavior, etc. Putting it all together and working with the Imperial College model of malaria transmission. And so this was the modelling part was led by Tom Churcher, and try and see if we layered on all the different interventions that were currently being used. Clearly, in this part of Burkina Faso, malaria cases are at best stable or possibly even rising. And if we started to think, well, what if we had a net where the mosquitoes were not resistant to, so we didn't have insecticide resistance, what would happen? Or what if we had something that could effectively control a lot of outdoor biting? Or if we had 100% coverage with seasonal malaria chemoprophylaxis, and started layering on these things. And really in that part of the ecology there, where the mosquito numbers are so high, the conclusion was with existing tools, we couldn't eliminate malaria from that setting. We could get it down to much lower levels if we had, we layered on the existing interventions, and particularly if we had a net that was effective in killing mosquito populations. But yeah, the conclusion there was elimination is not possible with current tools. But that's one setting. I'm not saying it's not possible in other settings, but
yeah. Yeah, Hilary, part of this interest in elimination has been driven really from 2015, driven a lot by the observations and the calculations that bed nets and indoor residual spraying, vector control in general, were really the major contributors to the gains that we had against malaria. And so a question for you and Corine, either of you can answer this, is whether that optimism that came was taken a little too far, or if the communication strategy around this publication, specifically by BAT, was a little too excited. Do you think that the communication around the power of vector control was much more than the observations itself themselves?
Hilary?
So yes, so I think two things about this very influential publication, which we cite very widely. I mean, firstly, it's looking backwards. It's historical data to see, well, this is what the impact of nets and IRS, etc., has been, and that, so when you've got a new tool, it's quite the first. You can have a big impact very quickly, but then there's the hard to reach populations, or the last mile and removing the large cases, or reaching the other populations can be more tricky. So it's sort of that the scale up of nets had a massive impact, but it's like, you know, it's like all tools, it's likely to plateau in the impact that you see. But also that this modeling exercise was done in the assumption that you had mosquito populations that were susceptible to pyrethroids, and so it was assuming, and which was correct, you know, in the early parts of this century, that most mosquito populations would be killed by the pyrethroid insecticides, and so the nets would have the personal barrier effect, but also a community effect, and we know now in large parts of Africa that that's not the case. So it what we saw sort of 10 years ago is quite different to what we see now. So I don't think it was inaccurate, but I think it was a snapshot in time, which is not the case now.
Right. Corine, my colleague Sheila will proceed with this, but before that, I have some questions specific for Corine here. Corine, you worked a lot on bed nets and indoor residual spraying, and just before we begin, I have a simple question for you to just clarify if these statements are right. The current bed nets that we have, the ones that are approved, have only pyrethroids, or pyrethroids and a synergist PBO, or pyrethroids plus another active. Is that the only classification we have?
Yeah, I think that this is the sort of classification that the PQ, that's the pre-qualification team, has. Yeah. We have nets that have only pyrethroids, nets that are able to kill, and we have nets that have pyrethroids and clofenapyr, like Interceptor G2, that has been listed and is being evaluated in large-scale trials. And we have nets with PBO, pyrethroids and PBO, which are also being evaluated in large-scale trials, and then nets and pyriproxyfen. And the main nets that we have with pyriproxyfen at the moment, which is being also evaluated, is Royal Guard. So I think this information here is accurate for the types of nets that we have available at the moment. Yeah. Yeah.
Do you have any bed nets that have PBO or any synergist plus other non-pyrethroid actives?
At the moment, no, I haven't come across a net that has pyrethroid, PBO, and another active yet. Yeah. Maybe there are some in the pipeline in some companies, but I haven't been approached with any net of that sort. And I don't think there is any that has been listed by WHO with that design.
Yeah. 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 A final question on this slide is, people always say that for indoor residual spraying, you have the advantage that there's much more than pyrethroids that you can use. That you have, you know, options to use carbamates, for example, organophosphates and neonics. However, Hilary was talking earlier about susceptibility and resistance to some of these chemicals. Are those real options at the moment, or do we actually have much more limited options than those, if you were to consider resistance?
Yeah. Yeah, if you look at resistance, because now we know pyrethroid resistance is almost everywhere, but we are also having increasing resistance to carbamates and organophosphates. So there are many vector populations where they have reported multiple resistance to multiple insecticides. So in effect, it's good that we have these other options which are non-pyrethroid, but also there is the fact that multiple resistance is kind of spreading. It's also worrisome because it makes some of these other non-pyrethroid actives to be difficult to use in those areas. You don't expect much if you use them. But at the same time, IRS, the advantage of IRS is that we could also deploy them in a rotational manner. So it's still good to have these at hand and we can rotate between these actives. But I still think it's very limited and we need to look into getting more options. I think the more different types of insecticides we can have, especially for iris, the better we are equipped to manage resistance and fight malaria as much as possible. So for now, just having a neonicotinoid as the only sort of new insecticide is not enough. We need more actives here.
Thank you so much. Thank you so much. Sheila, back to you.
Yeah, thanks, Fred. So Professor Corine, the WHO has obviously outlined the different testing guidelines for bed nets and for insecticides for IRS. Could you please take us really very briefly on the different pathways or the different testing methods that are usually followed when testing these new products that come into the market?
Yeah, okay, I'll begin with insecticide treated nets. And I think the first thing is to be able to test the net in the laboratory. And WHO has actually elaborated really clear guidelines that were developed under the WUPES, even though I think some of these need to be updated, but they are really clear. And in laboratory studies, which are defined as phase 1 studies, we test the nets to assess mortality against well-characterized strains, looking at other properties as well as knockdown and all of that, and also to see how the insecticide regenerates within the net, how many days it takes for the insecticide to regenerate after washing, and if the net is able to resist multiple washes. And if the results meet the WHO criteria, which are well set at the levels of mortality, that's about 80% in cone bow assays and in tunnels and things like that, then the net can move into small-scale experimental herd studies. And in those studies, they are tested in the presence of a human in the experimental herd. And we want to see the levels of mortality we get against free flying mosquitoes that can enter those herds, and to also assess how the insecticide is handled and perceived by people sleeping in those experimental herds. And following from that, those nets can also be tested in a large-scale field trials where we can assess their operational use, their acceptance, and also their kind of durability over time to see if the fabric or the quality of the fabric that is used to make the net can last at least 3 years as set by WHO. And for IRS, the process is actually the same. It also goes through the phase 1, the phase 2, and the phase 3. In the phase 1, we treat blocks in experimental herds of different types of substrates to see how far the insecticide can last on these different types of substrates, and also look at what dose could be operational for that insecticide. And after that, we go to experimental herds as well, and then to phase 3 trials where it's applied in communities, and then we assess the impact of the insecticide on vector populations, on transmission indices.
Mm-hmm. Yeah, thanks, Corine. So are these the same guidelines that are followed during the non-inferiority studies for both bed nets and IRS?
Yeah, the non-inferiority studies are a bit different. Basically, the methods are the same. I think the WHO came up with the idea of non-inferiority studies because we started to have nets that were being developed that were similar to other nets. But then would a company be required to maybe conduct an epidemiological trial for its net to be approved? That would mean that we would have so many different trials being conducted, and that is not really feasible in terms of the cost and the time it takes. So if a net from a given WHO class that has been developed, that has been approved, is submitted, and I think the idea is to be able to test that net against a net that has already demonstrated efficacy in epidemiological trials. And the difference simply here is in the way the data is analyzed. I think there is not much of a difference. I think the new guidelines on non-inferiority provide more details on the testing procedure, but the way the data is analyzed is different. It is weighed. You have like a comparison between mortality that is with the new product and the first-in-class product. And there is a non-inferiority margin of 0.7 that you have to use for that analysis, also for blood feeding inhibition. And then the data is reviewed based on those parameters, and a product can be classified in the same class as the one that already had a listing as a first-in-class product. Yeah.
So does it mean therefore that in the non-inferiority test, the question is whether the new product is better than the existing product, or is it worse than the existing product?
I think the idea is that the product is no worse than the existing product by a defined margin. So the WHO defined a margin that it will use to compare the new product to an existing product. Yeah.
Oh.
Mm-hmm. Yeah, thanks. I think we'll go into greater detail. But when you're thinking about these non-inferiority studies, and I think when a program is thinking about selecting a specific type of bednet or a specific type of the one of the new bednets that have come in, what are some of the endpoints or entomological indicators that the program should be focusing on? Because when you look at these results from the non-inferiority studies, you see many endpoints, and sometimes it's a bit confusing. But if the program wants to choose a bednet that best suits their scenario, what are some of the indicators that they should be looking at?
I think if you want to select bednet based on herd trial data, I would go more for mortality of mosquitoes that are relevant to the context of that country. So ideally you should have herd trials that are conducted in that country, or a country with a similar ecological setup as the country that is wanting to select a net. But I would be focusing more on the levels of mortality that this net can achieve against wild mosquitoes in that population. But another thing that can also be considered, which is equally important, is the level of blood feeding inhibition that a net can achieve. But from the data that we have seen being modeled from experimental herds, I want to believe that the levels of mortality usually are more kind of linked to the levels of transmission control that we could achieve in the community.
Mm-hmm. Yeah, you talk about the experimental herds. Looking at the slide that we have in front of us, so we have different types of experimental herds. We have some from East Africa and others in West Africa, and we have an Ifakara experimental herds. Could you briefly explain what the differences are and what the thinking is behind interpreting the data that comes out of experimental herds?
Going back to the history of these herds, I believe that the herds were adapted to the kind of houses that were found in those areas, because in East Africa, this is the kind of design that you would see, and in West Africa, you would see a design where you had small windows through which mosquitoes can go in. So it really depends on the setup of housing in that area. And the main difference, because I believe that there are major differences between these herds that could actually affect how the data, because you could not get the same levels of mortality in the same with the same products in these different types of huts. And it's also the way the mosquitoes enter and exit these huts. In the West African hut, we have just a 1 centimeter gap through which mosquitoes can enter, and they exit through a really large veranda trap. And in the East African hut, that's a bit different. You have just window traps that are set up in the East African huts that collect exiting mosquitoes. So I believe that these differences could have some impact on how the levels of mortality or the outcome measures that we are interested in when evaluating different products in these experimental huts. But as long as these comparisons are made with our controls in each of the trials, I think that we could manage to really interpret data with these huts.
Well, we have a...
Thanks, Corine. Yeah, go ahead, Fred.
That's okay. Is that okay, Sheila?
Yeah, I just had one more.
Go ahead.
Can you hear me?
Yeah, go ahead.
So Professor Corine, I just had one more in relation to the experimental hut assays and relative to the new insecticides and the mode of action of the new insecticides. So when you look at pyriproxyfen and clofenapyr, they have really very different modes of action. And the experimental huts tend to measure specific modes of action. So we have mortality, feeding inhibition, deterrence, and so on and so forth. So how then do you measure efficacy of this or test efficacy of these new active ingredients in experimental huts?
Yeah, I think for nets that contain clofenapyr, the main outcome you want to look at would be mortality. But for nets that contain pyriproxyfen, you want to go beyond just measuring mortality, because the mode of action of pyriproxyfen is to sterilize mosquitoes that survive exposure to the net. So if a mosquito survived because it was resistant to the pyrethroid, then we expect that it is also sterilized by the pyriproxyfen in the net. So you want to be able to collect those surviving mosquitoes and maybe bring them back to the lab and assess the impact, the sterilizing impact of pyriproxyfen on those nets. And what we have done in the past, we have 2 methods of doing that. You collect the mosquitoes and you hold them in oviposition chambers and allow them to lay eggs, and you compare that to a control. And our results have consistently shown that you would have more mosquitoes being sterilized in the arm that had the pyriproxyfen net compared to the one that did not have the pyriproxyfen net. And another method could also be to bring back these mosquitoes and dissect them and sort of observe their ovaries under the microscope to see whether they had a fully developed ovaries or not. And we have also shown that mosquitoes that are sterilized do not have fully developed ovaries. And you see that impact more with pyriproxyfen nets compared to nets that don't contain pyriproxyfen.
Yeah, thanks, Corine. Back to you, Fred.
Okay. Thank you, Sheila. And I would like us to bring back Professor Hilary and to talk more about bed nets again and indoor residual spraying. Actually, to begin with, I don't know, Hilary, if you're conversant with this process, but I would also like to appeal to our colleagues on the chat box. If there's anybody who is conversant to anything we are discussing here and they would like just to come and help us explain it, please let us know. You can do this via the chat, or you could just turn on your video respectfully and help explain this. The question, an important question for people working on vector control is, what do I do when I develop a new product? Where do I go? What is the pathway for it to get eventually pre-qualified and listed by WHO? And I know that we have with us the chair of VCAG, Professor Heather Ferguson. I hope she's on the call. Hilary, you interact a lot with this system. Could you just explain to us briefly? This is a diagram from WHO documentation. What do I do when I have a new vector control tool and I would like it to be pre-qualified?
Sure. So I think, well, it really depends on whether your new tool belongs to what's called an existing product class. So Corine was talking earlier, and we talked about non-inferiority trials when you've got products from different manufacturers, and you want to know, are they good enough? Do they meet the same standards? Are they as good as existing products in that class? And so in that case, it is simpler because we already have, there'll already been what's known as a first in class in that product. There'll be a product that has typically been through clinical trials, epidemiological trials. The public health value of that product class will have been demonstrated. And then you would need to demonstrate that the new product you had in that class was as good as. So that would be entomological evaluations of the sort that Corine just described. But if you've got something completely new, so that it could, so the easiest case is probably a new type of bed net. We start with a new class of bed net. So now WHO have defined sort of 3 categories of nets, as we saw on the previous slide. So pyrethroid only, pyrethroid plus synergists, or pyrethroids plus another active ingredient. So if your product, if your new net falls into one of those categories, again, you can say, okay, there's already data here. WHO have made a statement to say that these products in this class have a benefit under certain settings. There's a policy statement on them. And so again, it would be entomological evaluation. But if you've got something very new, and there are lots of examples of those, if in vector control at the moment, lots of different products that are have been evaluated in some either small or large scale trials, but as yet there's no real policy statement on them. And that's because although there may be data from studies showing that this new product might kill mosquitoes or prevent biting, what the evidence gap is whether if you use this product at scale, whether it could actually prevent or reduce malaria transmission. And so in that case, then there would be a requirement for at least 2 clinical trials to show that if you use this product in 2 different settings to see whether there was a reduction in malaria transmission or if there was a public health impact or the product had public health value. So in that case, that's where VCAG comes in the whole sort of WHO different committees. So there's the Pre-Qualification Pathway, PQ, and there's probably people on this call that are much better qualified to talk about this than me, but that they would look at products within the performance of products within an existing product class. But if it's a new product class, then it would go to VCAG, Vector Control Advisory Group, who would then be able to advise on the type of evidence or give feedback on trial designs to say, if you completed these trials, would there be a sufficient body of evidence for WHO to then be able to make a public health recommendation? So I think when you've got a new product, it depends on whether it's completely innovative, in which case there is a long pathway to getting a policy statement or from WHO, or if it's something that's similar to existing products that already have a policy recommendation.
Would you like us to check if there's someone on the line who would like to add to that? If we have anybody from PQ or Heather, if you're on the line.
Hi, this is Heather. So I've got a mouthful of food because I'm teaching in 10 minutes. Right. So yeah, no, the process as Hilary described is correct. So the direction you go will very much depend on that initial assessment of where your product falls within, whether there are other product classes that have a recommendation already and have demonstrated epidemiological impact, and that's a quicker process, or if it's something completely new for which it goes through VCAG. I've put in the chat some documentation from VCAG, from WHO on that process. And I'm also just about to put the updated vector control guidelines, where it's got the latest sort of summary of where everything stands with respect to what existing products or approaches already have the policy recommendation and the level of evidence and how that varies. I mean, there's a lot more to be said about that, but it sort of depends on the specific question people might have.
Thank you. Thank you so much. Thanks a lot, Heather, and thanks a lot, Hilary, as well. I think we're going to move on. Shall I have a question?
Yeah, there's a question in the chat that is related to this. I'm sure we'll look at it later, but just in case we forget. So there's a question from Amy. So it goes, does the WHO pre-qualification assess the availability and regeneration capacity of new ingredients like PBO?
Good question. Hilary, you want to check that, or Heather?
Yes, so yes, and in the process that Corine outlined earlier, the different phases of laboratory experimental huts and village trials, part of that will be looking at regeneration time. But and there's also a requirement for nets to be washed 20 times and look to see how long whether the insecticides remain active after this number of washes. But there's lots of debate at the moment about how relevant that is as a metric. 20 washes is a bit arbitrary. And what we don't know, and because it's one of the challenges with studies on nets, is that they are intended to be active for 3 years in the field. So to really understand how well these products last, you need trials that run for 3 years. And that adds a long delay when we've got problems with existing products. So it is, so to answer the question, it is looked at, but in perhaps what might be considered a bit of an artificial way. It's done trying to accelerate and mimic what net wear and tear and lifespan of the net would look like over 3 years use by doing 20 washes and doing an experimental hut trial. But there's lots of questions coming and from data that's emerging from longer term durability studies of new classes of nets about whether the two active ingredients, so be that pyrethroids and the synergist or two insecticides, whether they do both remain active for the full length of the intended 3 years of the product. What happens if one decays much more rapidly than the other? So you end up maybe after 1 year with a net that just actually only has one active ingredient instead of two. And so we really do need the results from these large scale durability studies that would run for the full 3 year expected lifespan of a net. And when we look at those, even for existing pyrethroid only nets, I mean, the results can be very depressing sometimes. The products do not last as long as we would have hoped, and certainly people procuring those would have hoped. So
Thanks a lot, and we will be coming back to many of these issues in the course of this masterclass. I want us to move forward to, I mean, this busy slide is meant for Professor Corine Ngufor. Corine, this is on behalf of myself and many people on the line, on behalf of myself and a lot of citizens or residents of the malaria endemic communities. If I look at, so the list you see here is the products that are currently pre-qualified by WHO for vector control, bed nets and IRS. And I cannot fail to notice just how many of these products you yourself, Corine, have tested. It's you probably tested 50% of them. It's probably based on your data and your work and your collaborations and your fellow experts that these products have been qualified. And this is a great service that you've offered to the community. It's a great service that you've offered to Africa and to other malaria endemic countries. And I think on behalf of myself and anyone else, I just want to say thank you so much and Congratulations. Yeah, there's no question on that. It's really just to really say we appreciate the amount of work you guys have done to get these products available for procurers and for people who need them. Hilary, back to you. In 2010, you and the colleagues wrote this paper. In the paper, this statement appears. When you read it today, 10 years later, how much has changed? Are we better than we were in 2010?
Things that you've said in the past. So I think that a lot has changed, but I think there's a lot of confusion out there about the impact of insecticide resistance. And one simple reason for that is it will not be the same in all places. Resistance isn't a binary trait. You're not resistant or susceptible. Mosquitoes will have different degrees of resistance and will have different combinations of species that are responsible for malaria transmissions in different settings. So understanding the impact of insecticide resistance is therefore complicated, much more complicated than understanding the impact of drug resistance, for example, where you can just look to see if your parasites are dead or not, or if people are clinically cured of malaria. But with insecticide resistance, it depends on the mosquitoes, obviously, and so the whole dynamics of transmission impact on the impact of resistance. So I think it's complicated, but there have been a number of studies that have been completed in the last 10 years probably now, and specifically trying to address the epidemiological impact of insecticide resistance. And I guess I can give you my opinion of what I think, what I would say is the evidence and the strength of the evidence, but everyone will have a different opinion, and as I said, it will depend on what setting you're talking about. And perhaps I could just say, so I think there's another important thing to think about when we're looking at how we interpret results from these studies is, particularly we're thinking about the impact of pyrethroid resistance on the performance of bed nets. We've got to think about what are we looking at, whether somebody who is sleeping under an insecticide treated net is still better protected from malaria than somebody that doesn't have a net. In which case the answer is almost invariably yes, because regardless of how resistant the mosquito populations are, because there's that physical barrier. So always sleeping under a net is better than not sleeping under a net. And that was the sort of conclusion that came from the studies that WHO commissioned. It was a 5-country study looking at the impact of resistance. And there, I mean, I'm just really broadly summarizing a huge amount of work and lots of very interesting data that came out of the individual studies. But as I saw it, the main conclusion was, yes, nets still work regardless of resistance. And we would expect that because there's a physical barrier. But what about people that don't have access to nets, or if there's a lot of outdoor transmission or early evening transmission, etc. There you're relying on the community protection provided by the nets. And so the fact that a mosquito that comes into contact with a net, if the insecticide is active, the mosquitoes are still susceptible, the insecticide will kill the mosquito. And so those people without a net, or those people that are sleeping outside for part of the night, or mosquitoes are biting earlier, are still protected. And that's where we see the impact of resistance. We start to lose that community protection, which is much harder to assess in a clinical trial, because you need to know exactly who's using a net when, and you can't just look at net users and non-net users. So when you start to look at that, I think the evidence for that pyrethroid resistance is undermining the performance of nets become stronger. But I'll just say one more thing before opening it up for others, but just I think perhaps the strongest evidence that we have that pyrethroid resistance is impacting on the performance of nets is the results from the trials looking at PBO nets. So when the two trials now that have, two clinical trials that have looked at the impact of adding the synergist PBO to a pyrethroid bed net, both show very substantial improvements in malaria prevention when you've got PBO. So if pyrethroid resistance wasn't a problem, and the pyrethroid treated nets were working as they were originally when mosquitoes were susceptible, we wouldn't expect a network synergist to be any better. That PBO is only any benefit if you've got pyrethroid resistant mosquitoes. So I think that the results from those trials really drove home to me, at least, that there is clear evidence that pyrethroid resistance is undermining the performance of insecticide treated nets in large parts of Africa.
So given that indirect, well, not indirect really, but that observation from the PBO test, there are people who have argued that it is more of a demonstration of these nets killing more mosquitoes rather than resistance impacting on nets. Is this a question of trial designs not being suitable for this question?
Well, they are killing more mosquitoes. I mean, well, it's very, I guess, one of the other challenges of looking at the impact of resistance is, I mean, an ideal study design, you'd have an area where mosquitoes were susceptible to insecticides and an area where they were resistant. And you had the same vector species and the same behavioral patterns, and you would compare how effective your product was in those two settings. But it's very hard to find a fully susceptible population across Africa at the moment now, fully pyrethroid susceptible population. So study designs are necessarily limited, but I still think the fact that you see, and as Corine said earlier, in answer to one of Sheila's questions, the key indicator you're looking at from these studies is, do the mosquitoes die? And the fact that more mosquitoes die with PBO, I mean, so a fully susceptible population of mosquitoes would die with pyrethroids only. So adding the PBO wouldn't make any difference. So the fact that you get more dying with the PBO, to me at least, suggests that it's that the mosquitoes are not, the pyrethroids alone is not enough to kill those mosquitoes.
Okay, thanks a lot. Sheila, did you have a question on this as well?
Not at the moment. I think we can take the following slides.
All right, brilliant. So given we're talking a lot about insecticide resistance, Hilary, and Corine, don't mind that we're putting you on the balcony a lot longer. Hilary, if you don't mind, we would want some basic explanation here about the subject of insecticide resistance. We had a fantastic masterclass here with Professor Charles Wanji, and he explained much of this to us, but then there's the number 5, the item number 5. This is a new insecticide resistance mechanism that your team has described recently, I believe 2020 or 2019. So in summary, you have this metabolic resistance, and in 2002, I believe, you described in very good detail the supergene families associated with this. Then you have the behavioral, the cuticular, and all that. But we don't have a very good explanation for this sub-2. And our question is whether this is a separate resistance mechanism or if it is an expression of one of the above.
Sure. So it is a little bit of a mystery to us as well, I have to say. It's definitely a work in progress. But essentially what...
Actually, we have a slide for it over there, so just in case you want to use it.
Right. Yeah. So let me just say a little bit about how we discovered that this mechanism was important, at least in Anopheles coluzi in West Africa. So this was work that was done by Vicky Ingham, who was a PhD student in our group in Liverpool at the time. And she looked at data from populations of resistant and susceptible populations of Anopheles gambiae complex across Africa, and compared the total gene expression in resistant versus susceptible, just to see if we could see anything by doing this sort of meta-analysis of all these different studies, if we could identify anything other than what we knew already, which was, as you've seen on the last slide, we know that there's P450s, we know there's evidence of cuticular resistance, etc. We knew about those, but we wanted to see, was there anything else? And what came out of that study was a number of gene families that are associated with insecticide binding. Well, not insecticide binding, with binding generally, binding proteins. So things like hexamerins or crystallins, that their general function appears to be sort of moving things from one part of the body to another in insects and in other invertebrates as well. So we saw a lot of these binding proteins overexpressed, and one of them was a few of them belong to a family of chemosensory proteins. So chemosensory proteins are generally associated with detecting odor, or also by touch, like so recognizing the senses, I guess. But these chemosensory proteins, a subfamily known as the sensory appendages proteins, or SAPs, they're expressed in the legs at very high levels and also the antennae. And so so we found that these proteins expressed in the legs, they were highly induced after pyrethroid exposure. And then what Vicky did there, and what you can see on this graph here at the top, and so it's a bit of there's a lot of information on here, but she essentially used RNAi to try and to reduce the level of expression of this SAP2 gene, and found that so each of these pairs of bars here shows a control, and then one in which you've knocked down the SAP2 gene, and then it's looking at the mortality after exposure to different pyrethroids. So this first one here is in a population called Tiasley, which shows that knocking down SAP2 dramatically increases the mortality after delta methrin exposure. So effectively, what we could show was that by partially knocking down this one gene, we could almost restore susceptibility. And then working with John Vontis's group in Crete, that they were able to show that this SAP2 protein efficiently is a really tight binder of pyrethroids. So this is showing delta methrin here on the left, and the red is SAP2, and it's just a binding assay that shows that SAP2 binds pyrethroids. So so in summary, really, what we could see was that there was this chemosensory protein in the legs that is induced after pyrethroid exposure. It binds pyrethroids, and if you knock it out, if you reduce the levels, the mosquito is no longer resistant to insecticides. And so now this was all done on a couple of laboratory populations from Cote d'Ivoire and Burkina Faso, but then we looked at other populations in West Africa, and we could found evidence that there was selection around this gene, that it had some sort of advantage, because if you look at the patterns in the genome, you could see that there was a selective sweep around this area of the genome. So exactly what it's doing is still a little bit of a mystery. Our hypothesis is that it is because the insecticides, the way we use insecticides for malaria control is always by contact, or almost always by contact. So on the net or on the wall, mosquitoes' legs land, or its legs and antennae will contact the net, and that insecticide has to get absorbed through the cuticle to reach its target site in the nervous system. So we think that the exposure to the insecticide is inducing the expression of these proteins that are binding the insecticide, and either maybe excreting it, or maybe just sequestering it, keeping it in the legs, or possibly even transporting it somewhere else in the mosquito's body that speeds up its detoxification. But they're basically reducing the amount of insecticide that reaches the target site. And these proteins may be critical in the transport of insecticides in susceptible populations maybe, but in resistant mosquitoes where you've got much more of them, they sort of mop it up and reduce the total availability of insecticide. So we think that we've shown that in these populations from West Africa, this is a really potent, powerful resistance mechanism. We think it's quite new, and that's from evidence from looking at patterns in the genome. It looks like it's a relatively new a gene that's been selected for quite recently.
Yeah. And
we wonder if it might be, that it might be something that when you get such high intense selection pressure, first of all, you get target site mutations and metabolic resistance, and then eventually you get the evolution of additional mechanisms. But we need to look in other populations to see if that's the case.
Yeah. Thank you so much, Hilary. A separate question related to this, which you don't have to respond to now, we can chat about that later, is whether this, expresses singly or always in addition to the other mechanisms. And we can comment on that in the next slides. I think, Sheila, I'm going to drive this back to you.
Yeah, thanks, Fred. So given the complexities around insecticide resistance mechanisms, and this is to you, to both of you, Professor Hilary and Professor Corine, given these challenges that we have in place, is it really, how do we measure operational failure of these vector control interventions, given the test methodologies that we have in place and the gaps that we are now seeing, given the new products that we are now coming up?
Corine, do you want to take this, or?
Yeah, I can start it, and Hilary can add to that. Yeah, I think this slide clearly shows what we should be testing if we want to see whether a population is resistant to an insecticide or not.
You want the other slide or the previous one? Sorry for interrupting. Is that okay, or this?
Yeah, it's okay. And then after you can shift back to the previous one. So it's the WHO method uses cylinder bioassays, and mosquitoes from a given population can be tested in these bioassays using a discriminating concentration that has been defined for a given insecticide by the WHO. And when they are exposed, we assess mortality, and there are different levels of mortality that are used to maybe describe the population in terms of the levels of resistance. So resistance is confirmed if mortality is less than 90%, then you start to really think about resistance. But the issue with these assays is that it's a single dose, and it actually just gives you more of a starting point as to maybe thinking about really going deep into what resistance means for your population. So there are other methods to consider to be able to really have a better kind of interpretation of how resistant your population is. And we could look at more at intensity bioassays to look at different concentrations, like those response assays, to look at different concentrations and compare that also to a susceptible population. And that way you could maybe define resistance ratios and all of that. And I also want to add that these discriminating doses have been defined for mostly existing insecticides. But for new insecticides, which are now being deployed in different countries or being piloted in several studies, especially in Africa, we really do not have yet discriminating concentrations. And there are studies ongoing to be able to define these discriminating concentrations. And it is important that populations are monitored as much as possible using a resistance bioassay, so that we are not shocked when resistance developed to some of these new actives. It will be really devastating, because we need to start as soon as possible to apply resistance management strategies to be able to hold back resistance to these new actives as much as possible.
Yeah, thank you, Professor Corine. And Hilary, please hold your thoughts a bit. I have a follow-up question for Corine. When thinking about testing of insecticide resistance or monitoring insecticide resistance at the program level, so for the vector bionomics side of things, the WHO has guidelines on how to select sentinel sites, on the criteria that should be followed when selecting sentinel sites. So when we are thinking about monitoring of resistance, how should we be selecting the sentinel sites? Should we even have sentinel sites in place for monitoring resistance? Or is it maybe we should be going out and, you know, actively looking for areas where we would find resistance and not just have fixed sites for resistance monitoring? What are your thoughts there?
Yeah, personally, I would be in favor of the second option because we really want to hold back resistance as much as possible. So I think that monitoring resistance should not just be fixed to certain sites, but as far as a program can test as many sites as it can, it depends on what resources they have and how far they can go. But if they can expand that to go beyond what the WHO has defined as sentinel sites, that would be good. It would be essential for their program so that they can take action as soon as they start to notice resistance in their vector population.
Yeah, thanks, Corine. Professor Hilary, do you like to add on?
Sure, thanks. Yes, so I agree with everything Corine said. I'd just like to reiterate the difference between the different purposes of resistance monitoring, I guess. So sentinel site monitoring, I think, is really useful to see changes over time. And using this WHO susceptibility tests tells us when resistance emerges in a population and the prevalence or the frequency of resistance in that site. If we add the intensity assays, we get a bit more information about how strong that resistance is. But this is for surveillance purposes, and these tests should not be confused with tests to see whether you've got operational failure of current tools. They will give you an indication that it may be due to resistance, but the amount of insecticide that's on the insecticide concentration used for the discriminating dose assays was designed to be a sort of sensitive test to detect the first emergence of resistance. They're for monitoring, but it doesn't mean that just because you've got 70% mortality in a discriminating dose assay, and last year you had 100%, that your nets won't work. It's not measuring the same thing. And I think, yeah, this slide is looking at other ways in which we might look at that more. If your question is not how resistant is my population, but is how well are my insecticide-based products performing, then you need to use the actual product. And so that's when you use things like cone tests on the nets themselves with your wild-caught mosquitoes to see whether they are still killing mosquitoes. And if you can, you do experimental hut studies to see whether your nets are effective under more realistic exposure settings.
That's actually interesting, Hilary, because when you think about efficacy of bed nets and IRS, like operationally, we use contests, and I think you have mentioned that we should be using contests. But then when we are thinking about contests, we use susceptible mosquitoes.
Yeah.
So then why are we using susceptible mosquitoes instead of using field collected mosquitoes?
So I think if you're trying to look at the durability of a product, so for IRS and you want to see how many months after spraying is it still active, then yes, you should be using susceptible mosquitoes because you want to check it still works. But I would advocate that there's a role for cone tests as well in telling you if you've got a brand new product or a freshly sprayed house and you take your field mosquitoes and you expose them, it's the same test but answering a different question. Does this product used as it's intended still kill my local vector population? So it depends what question you're trying to address, I think.
Yeah, thank you.
And I just want to add to that because sometimes there is the the confusion of some programs testing an insecticide or evaluating or monitoring an insecticide for iris, for example, and they could focus more on using the wild population. But if you want to really look at the residual efficacy, you should be using a susceptible population, just so that you don't have variation in the mosquito. Your mosquito would vary depending maybe on different times you collect them in the field and all of that. But if you want to look at residual efficacy, you should be using a well-characterized strain and for which you know the levels of resistance, or you are sure that it is susceptible to the insecticide in question.
Yeah, thank you. Back to you, Fred.
Thanks a lot, Sheila. And before we continue, I would just like to encourage to recognize the active discussion on the chat box. Thank you all for the engagement. And again, because we have so many experts in the event, in the class today, we encourage you to participate in this discussion, and we really appreciate it. Thank you so much for this activity. If there are specific questions that must be addressed by either Professor Hilary or Corine, we encourage you to just respectfully turn on your microphone and let us know, so that we can address these questions going forward. The next question we would like to discuss here is with the next point is with Corine again to begin, and this is the question about combinations. When is it appropriate to use bed nets and indoor residual spray in the same location? And Corine, you yourself have done tests with organophosphates and pyrethroid nets, and your conclusion in some of these studies have said that there's not really much additional value. There's one study from Tanzania by Philippa West that demonstrated additional protection whenever you combine bed nets and IRS. WHO has a statement about this, preferably use only one of them instead of two. It would be nice to hear your thoughts on whether this is something that also depends on ecological settings, or if this statement can apply to most cases. Back to you, Corine.
Yes, I think that the use of combinations has been an argument that has been ongoing for a long time, and it's only recently that this WHO guidelines actually recommended against using combinations based on studies that did not really show a consistent advantage of using the two. But I think it comes down to several factors, and it depends on the ecological setting, like you said, the kind of resistance in the vector population, what type of combinations you are looking at. So there are many factors that need to be considered that's going beyond maybe the cost effectiveness, because maybe a program doesn't just have enough money to go around deploying both interventions everywhere. So, but then we from the studies that we have conducted, we have shown that for example, resistance plays a key role. When we did a trial testing combinations in Burkina Faso, in an area where we didn't have resistance to organophosphates, we were able to show some advantage of the combination in that area. But in an area where we had resistance to both insecticides, that's the insecticide used in the IRS and the ITN, we actually didn't see any advantage of the combination. The ITN on its own just was just as good as the combination. So there are several factors to consider here, and I think that it's not the advice is not really one rule fits everybody. I think each country would have different situations, and now I think there is even a greater demand on endemic countries to be able to really assess how they want to optimize their coverage of these different tools in the communities, because they have now to look at several different, all these factors before they can decide as to where they should be applying IRS to complement nets. But a general rule, I think, would be that if you think that your items are really not working, or you're not getting the level of control that you should, or malaria is highly endemic or burdensome in a certain area of the country, then you should think about adding IRS to that, because in some way there would still be some advantage of adding the IRS if cost effectiveness or cost was not an issue. Yeah.
Thank you so much, Corine. It's wonderful to listen to you describe this. And I think the point you raised about economics is an important one too. So thank you so much for that. Hilary, do you want to add anything on this subject?
Yeah, just maybe to say, I mean, I think Corine said already that, I mean, you'll get variation between the different studies depending on where they were done, the vector species and level of resistance. And I think that's something to consider when thinking about combining them. We know, and I think in the WHO's Global Plan for Insecticide Resistance Management, it talks very clearly about don't combine insecticides with the same mode of action, or don't rotate them the same mode of action. But I would just say, be aware also that you can get cross resistance between insecticide classes, not just due to the same target site, but because you've got the same enzymes involved in metabolizing them, for example, or cuticular resistance can cause cross resistance. So I think when combining or considering combining NETs and IRS, it's really important to do a full assessment of susceptibility to those chemistries before doing so.
Thank you so much. Thank you. Our next point, we would like to go back to the PBO, and Michelle and myself have a number of questions around this. So I'd like to go back to the issue of PBO bed nets, and there are two what you would call landmark publications on PBO nets in East Africa. The first is the Tanzanian trial you were talking about earlier, and the second is a trial from Uganda. Before we ask you the question, I just want to highlight the point that yourself, Hilary, and your team, before the Uganda trial came out, you already did this Cochrane review that made a recommendation for using PBO nets in high transmission settings, in high resistance settings, in strong resistance settings. The existing WHO policy recommends PBO for moderate resistance settings. Where is the mismatch? And there are two questions here. One, Sheila will talk about this, about how long PBO lasts. But the question I want to start with is, the WHO recommendation is about moderate resistance. The evidence we have from the Cochrane review you did suggests strong resistance areas. What is this about moderate resistance?
Yes, so maybe, so I think the initial recommendation on moderate resistance levels came, because at that time, there were the results from the clinical trials were not available. So this all came from entomological data. And it came from looking at a meta-analysis of experimental hut studies, and then using, and then Imperial College took that entomological data and used their mathematical model of malaria transmission to predict the public health impact of PBO. So it's trying to predict what the impact would be of PBO nets in the absence of any clinical data. And from the data available at the time, it seemed like there was a plateau effect, whereas PBO would increase the mortality of mosquitoes up to a certain point. And then when you got very highly resistant mosquitoes, from the data set available, didn't suggest there was a much smaller impact of PBO, and possibly because there are, in those really resistant populations, there are multiple additional mechanisms, not all of which are synergized by PBO. Though I know in the chat there's mention about PBO does increase the uptake of pyrethroids, and that's certainly true, and it does have an impact against susceptible mosquitoes, and that's also true. But we saw from the data available at the time that some mosquito populations could not be synergized with PBO. They were highly resistant, and even with PBO, you couldn't have didn't have an impact. So the modeling exercise that was done then predicted that the biggest impact would come from that sort of sweet spot where you had some resistance, because PBO would have no real added, there would be no need for PBO for the susceptible populations, but you had populations where adding PBO would increase the mortality substantially. So that was the prediction then. I think that was work done in about 2015, so 6-7 years ago. And then obviously a lot of work's been done since then, and there have been additional experimental hut studies being done in multiple settings with different levels of resistance. And of course, resistance itself has increased in some of the sites where the experimental huts are. So we now have a much larger data set to look at. And I think that's probably the main explanation for why, when we did the Cochrane review looking at results from the experimental hut studies, we found that the biggest impact here was seen in highly pyrethroid resistant populations. Now, it's also how you define resistance, because here for this Cochrane review, we just divided them into 3 subsets. So a highly resistant population in this setting was defined, I think, as mortality greater than 70%. Sorry, I'm getting that the wrong way. We divided into 3 into thirds, basically. So if you had less than 30% mortality, it was highly resistant. 30 to 60 was moderate, and 60 to 100 was low, I think was how it was done. So it's different definitions of what we mean by highly resistant. And if I might just add, we have just updated this Cochrane review, and it's back with the reviewers now for comments, but we've added in the second clinical trial from Uganda, which wasn't published wasn't complete when this Cochrane review was done, just to see if we can get an estimate for the impact of PBO nets. Yeah, summarized from both trials.
So we're looking forward to that, the new review, but you just mentioned the Uganda trial, and I have a specific question. Sheila, please stop me if you need to respond to ask this differently. Hilary, the trial from Uganda, which is the one on the right or left, is left or right, has very interesting observations here. If you look at the results that they're showing, they divide this in 6 months, 12 months, and 18 months, and they see a clear difference at month 6, but no difference from epidemiological outcomes at month 12 or month 18. But if you look at the conclusion, they are very strong about it. Their concluding statement is, this study provides evidence needed to support WHO's final recommendation. One of the major concerns about PBO has been, how long does it last? And I think the Uganda trial suggests that these differences are visible only in the short term. So how do we interpret this for actual implementation?
So I'm just trying to look, and I can't remember, but I think that this publication here, was this for the first 2 years?
This publication, and maybe actually Sarah, the author, is on the call. If anybody in this team is on the call, please let us know. You can explain this better to us.
Because there's been a follow-on study looking at, I think, month 21.
Okay.
But yeah, is there anybody on the call that's involved in this study? My understanding is that they did see a very high protection in the first 6 months, as you say. It then dipped, but then in the final study point, there was still significant protection from PBO nets. Yeah. And that's quite hard to explain.
Publication, there isn't much. But again, if we have anybody from this trial, please just respectfully turn on your video and let us know to explain. But other than that, Sheila, I know you have a number of questions on this subject as well.
Yeah, thanks, Fred. So the very first question is, since PBO is very specific to metabolic resistant mosquitoes, so what happens where you have metabolic resistance and, say, target site resistance occurring concurrently in a specific mosquito population? In that case, how does the impact or the efficacy of the PBO nets change?
So we've, I mean, I guess the simplest answer would be to test it on your population and to do a synergist bioassay, just to see if you've got any evidence of enhanced mortality after PBO, if you expose mosquitoes to PBO plus pyrethroids as opposed to pyrethroids alone. But because the PBO acts, and I know there's some industry people online who can probably describe this better, but my understanding is that it acts as sort of like an adjuvant. It enhances the uptake of the pyrethroids as well. So I don't think it is necessary to demonstrate that that your resistance is P450 based or metabolic based to come to decide on whether or not to use PBO nets. I think I would do a bioassay to see if you can see any evidence of enhanced mortality with PBO. And if you can, I wouldn't worry too much about the mechanism, because I think there's things that we don't know about exactly how PBO works as well. We do know it inhibits P450s. It's definitely a major mode of action, but if it also increases the penetration, then it could be effective against other resistance mechanisms as well. But I don't know, Corine, if you would agree, what would your recommendation be of when to use PBO nets?
Yeah, I think because I'm just thinking about what the WHO guidelines say, and it says to use PBO nets when you have resistance that is partly conferred by metabolic resistance. So it depends on how a program would want to demonstrate that they have a metabolic resistance in their population. So if they could do a PBO bioassays and demonstrate that there is improved mortality after exposure to PBO, then there could be a justification to apply PBO nets in that setting. As to how the uptake of PBO, of pyrethroids, is affected by PBO, and whether that would be still useful if the population didn't have metabolic resistance, that's another story. But another issue is that we have metabolic resistance almost everywhere now in Africa. So in the end, I think PBO nets would be useful in most of Africa right now.
Yeah, thanks both. So my follow-up question to you, Corine, is when you're thinking about the durability of these nets, so the survival of these nets or the efficacy when the nets are in the field, and from your experience in testing these nets in experimental huts, does the content of the PBO matter, and how does that change or vary across the testing period in the experimental huts?
Yeah, I think the content of the PBO really matters, and that is one aspect that differentiates between PBO nets, the different brands of PBO nets that are outside there. They differ in content and in the technical specificities. That's how the PBO was put in the net. There are some nets that the PBO generates faster. The PBO can be washed off really faster than in other nets. And we see really great differences between different types of PBO nets. And I think that there are studies going on right now, even some that are being sponsored by, I think, the WHO, the Global Fund, to actually test different types of PBO nets with different formulations and different specificities, different loads of PBO in them, and that would provide more information as to how the PBO changes. But also testing nets that come from the field would actually give a more definitive answer as to how these nets differ. But we will not be able to all PBO nets that are available in durability trials right now, bring them back from the field. We wouldn't have all that data right now. But I think there is really an important point here to continue to monitor the efficacy of these PBO nets and to be able to differentiate between brands so that different countries can get the maximum out of these PBO nets that seem to cost more than other kinds of nets. Yeah.
Yeah, thanks, Corine. And that's really interesting. And it's related to the question that I had previously on which mosquitoes to use for the durability tests. So when you're thinking about the PBO nets, should we still use susceptible mosquitoes for the durability, the insecticidal ones? Yeah.
Yeah, when we bring mosquitoes back, mosquito nets, that's PBO nets, back from the field to assess durability in terms of bioefficacy, I think we need to look at how the two active ingredients are changing over time from the field. And if you want to look at the effect on the pyrethroid alone, you may want to use on a susceptible strain. But if you want to look at the impact of PBO, given the mode of action of PBO, you should be using a strain that also has resistance, which can also be susceptible to the synergistic effect of the PBO in the net. So I don't think that doing a susceptible strain alone would be enough. So durability bioefficacy studies using PBO nets should include pyrethroid resistant strains, which have demonstrable metabolic resistance in them.
Yeah, thanks, Corine. So maybe this calls for an update of the current guidelines, since we now have new products in the market. Back to you, Fred.
Thank you very much. Thank you very, very much. Hilary, very quickly before we leave this session, and I see that we have one person on the line who really wants to tell us something, so I'm going to request Dr. Raga Vendra to very quickly mention.
Good evening. I'm speaking from India. We work on the major vector, which is here is Anopheles culciferensis. And the overall resistance to pyrethroids is around 20%, susceptibility is 20%. So we had made a pilot study with Permanent 2, which is a pyrethroid impregnated net in about 5 states and 21 districts. So we did not find any increased susceptibility, but only in one place we could find that the mortality was around moderate, what we call around 40 and 50%. And the enhanced susceptibility due to synergists could be found only in that place where it was around 40 to 50%. In other places, we got 100% mortality the moment we exposed it to the synergist fabric. So synergist bias is what we have done there. Now the issue is whether in areas where species like culciferensis is there, with the major metabolic resistance mechanism of PBO, can PBO nets be a success, or should it be used, or when it should be used? Thank you.
Hilary, you want to respond to that?
Yeah, I guess briefly, just two things. I mean, I think personally, if I wasn't seeing any evidence of synergism or not very substantial improvement of PBO, I would not be rushing to replace with PBO nets, but it depends on the cost. If they were the same price, the PBO nets will not, well, I say they will not be worse than standard pyrethroid nets. There are questions about durability that we talked about already, but they shouldn't be any worse than a standard pyrethroid net. So if they were the same cost, then yes, why not at the PBO? But from the data you're describing, and given my understanding that there is still quite a substantial price difference between PBO and standard nets, then maybe they won't be very effective in this setting.
Thank you so much, Hilary, and thanks to Dr. Rajabendra as well. I truly appreciate it. I want to move on, and Hilary, I want to bring you back to history. Not history really, but your early days working on this subject. This is a very interesting paper for me because the first time I ever investigated KDR, I didn't know much about the West versus East thing, and there was a lot of confusion in the lab at the time. You described in East Africa, Dr. Vulule and team, for the first time, a different mutation related to, similar to what it was in West Africa, but in this time involving seren. How has this changed today? This so-called KDR East versus KDR West, how distinct are they today, or is it now more homogeneous and they're everywhere?
Yes, I mean, I think
is this even an important question?
I think these terms are pretty obsolete now, really, East and West, because you find both these mutations across Africa in all members of the species complex, Gambi species complex, not in Phenestus, but in Anopheles gambi. And actually, things are moving on beyond these two mutations now, because we know Actually, what we're seeing in some parts of West Africa is that the frequency of KDR, this KDR that we're looking at here, standard KDR, is decreasing, but it's being replaced by a different mutation at a different codon. And we don't know why. Maybe it confers high levels of resistance or has less fitness cost or something. So yes, this again described the situation at a snapshot in time when the serine mutation did first emerge in East Africa and the phenylalanine in West Africa, but they have spread rapidly across Africa. I think the current thinking is that the serine mutation may have been selected for initially by DDT, and phenylalanine may be more a pyrethroid selection pressure, but I may have that wrong. I'm not fully up to date on that.
Was it a spread, or some of them emerged?
So both, actually, and some. Again, there may be people on the call that have done some of this work, but there were some very nice population genetic studies that have looked at the number of times that KDR, the classic KDR 1014F mutation, has emerged across Africa to look, and then how far that spread. And there's some very nice publications on that. But there's been at least 10 different emergence of the same mutation, but they have also spread widely as well, and sometimes spreading quite long distances as well.
Thank you so much, and we're going to move forward again to our colleagues on the line. Thank you so much. I'm wondering if our colleague Damaris is still with us. Maybe we can take a little bit of a break from the technical content here and have some personal discussions, which Damaris has kindly accepted to host. Damaris, are you still on the line? We could take a break and do this more personal discussion briefly and then proceed. Hi, Damaris.
Hi everyone. Glad to be here. Glad to listen to Hilary, Corine, powerful women, people that we look up to. Yeah, so a quick one, and I know I won't be going into asking issues to do with resistance. I won't be asking about the use of the control tools. Mine is more into gender. I feel that one of the gaps that is there is the gender gap, involvement of women in addressing issues to do with vector-borne diseases and more so malaria. So I'm glad to see, and you're the people we look at and know that there's hope for more women to come on board in tackling issues to do with vector-borne diseases control. So my first question, and as I said, I feel it's the gap that we are missing so far. If we are talking about elimination of malaria by the year 2030 in most of these endemic countries, I feel that we need to embrace gender. So my quick question to you, Hilary, to start with, is what systems and structures are there in place at the global level that are supporting or nurturing young scientists, more so women, to take leadership position in malaria control?
Oh, that's a big question, Damaris. So I think there's lots at different levels. I mean, I just want to give one example from last week, was the Women in Malaria scientific conference that was held obviously remotely, but I thought that was a very nice platform. The fact that it was held remotely enabled much broader participation, and I'm hoping that lots of networks and collaborations come out of that meeting. But in terms of more looking at leadership in, I mean, I say it could be taken at so many different levels. There are lots of leadership courses that I'm aware, and the work that PAMCA's doing in this area is fantastic. And I think, Damaris, you're probably best placed to answer your own question here. But I think what we clearly see a gap. Got a bit of background. Okay. Clearly see a gap is in.
Hilary, you're muted.
Yeah. Is that, can you hear me? I was getting a bit of feedback.
Yeah, sure.
Okay, sorry. Yeah, is that and I hope that you and Corine can maybe speak to this, is that when we many of my partnerships with malaria control teams or research institutes in Africa, and I go there and they all the trainees are men, or the head entomologists are men, and there's a real gap in female entomologists working in the field. And I'm often asking, where are the women? But I think that's something that maybe Corine could speak to.
Yes, Corine, go ahead.
Yeah, I think that we really have more of a lack when it comes to more senior scientists, more senior entomologists, especially, and even more among African women, because when you come to lab or an entomology research group, you would find that you have women at the lower level, maybe just assistants in the lab and all of that. But going up to become a really senior scientist and leading a program, you really find very few women. And to be honest, I don't know what the exact answer to some of these questions are. There is also the need for education, kind of sensitization of women. And there are real issues that could be holding back some women from engaging in these careers and going further. As an African woman, for example, myself, I think that one of the major setbacks has been the social setup also that kinds of limits the roles of women, or young girls are not aspiring to become really senior scientists because the culture doesn't look kindly on women who go that far. So there is a need for a good level of sensitization to encourage women to advance in these careers. So it's when you have reached a really good level as a woman that you can start to pick up other women. So I think that starting from the top and encouraging more women to reach high levels would have a kind of a feedback effect and bring in more women into vector control.
Okay, thanks, great response. I have a follow-up question with that. Most of statistics show that entomology is a male-dominated field, okay? And most people who take entomology, who are involved in vector control, tend to join the field, but they don't stay long. They move to other professionals. But for you, now that you're at professorship levels, you've remained all through. Okay, so have you managed to remain in this field, and what can you advise young people like us? I consider myself younger, but I know there are younger people than me. But what has kept you going? What has made you remain in this field for this long?
If I should start, for me, I wouldn't say it has been an easy journey. It's as you say, a male-dominated area, and sometimes you really have to be excellent to actually excel as a woman in this field, to be given the floor or given the space to take lead in certain things. So I think that there is really a need for more women at the forefront of fighting some of these, or in the area of vector control. So I would, for me, one of the issues has been networking and looking up to the few women that are already in the field. I've found myself in a network where I can actually be given the freedom to lead certain control programs, and you just have to be strong. Sometimes you have to overlook some of these difficulties and try to fight to get leadership. Yeah.
Okay, thanks, Corine. I don't know, Hilary, if you have something to add.
Yeah, I would echo everything that Corine said. I think forming networks, I mean, I've been inspired by many excellent female entomologists, and forming networks and then trying to support, now that I'm old and I'm able to, in a position where I'm able to hopefully provide some support to female and men, but particularly trying to encourage more female entomologists into the field. And I think events like the PAMCA, I mean, I learned so much from the discussion at the PAMCA meeting a couple of years back about just hearing some of the real lived experiences of women and what they've experienced trying to do field work, and the challenges of doing this. And I think talking about it more openly, talking about what some of the barriers are, because some of them can be removed when we know more about them. Others are very structural and very difficult. And we're hearing stuff in the chat about, education, etc. And obviously family practical things that we can do to make this a more open and encourage women that this is a profession and a career and a area of science that they can make a contribution to, because there's so much to be done. I mean, we desperately need more people working in this area. There's such a shortage of people working on vector biologists just everywhere, I think.
Yeah. Okay, great. From what you're saying is that one of the things is trying to have more women on board in addressing issues to do with, I'm sure, health related. And now that we're talking about malaria, what's your take about mentorship? How do you foresee mentorship as one of the systems or support tools in bringing more women on board, but also more so to support young upcoming scientists?
So I have mixed thoughts. I think, I mean, everybody, I guess I hesitate because I think it can be very unequal and very divisive. I mean, it's access to mentors. Not everybody has the networks, gets introduced, makes those connections, or finds a mentor that's willing to invest time in them. And if they do, I think that's incredibly valuable. But where I found it's a bit useful in my career is sort of peer-to-peer mentorship with people at my different stages of my career, my peer network, and supporting each other. I think I found that very valuable. So I think mentorship schemes are good, but I think that it's challenging to make that fully equitable and not become kind of like a clique of who knows who and who's got the funding to go to the conference to meet the people, which is why I really like the online conferences, I think, and the chats and the things that come from this. I think we can, I remember going to my first scientific conference when I was a PhD student. I absolutely hated it, and didn't know who to talk to, and it felt very intimidating. And I think we can start breaking down some of those barriers by having more online meetings. So yeah, mentorship, great if you can get it, but it shouldn't be the only way in which we try and support and encourage junior colleagues.
Sure. Yeah. Corine, any comment on that?
Yeah, I do agree that mentorship is really, it's a good way to go. And I think the challenge is creating the platform where people, mentors and mentees can meet. Yeah, and as Hilary says, I would just add to that, it's really having opportunities, as many opportunities as possible that people can meet from different areas of the world and in different aspects of vector control. So I think the Women in Vector Control, which you are leading, could be one of those platforms. So it's just about designing them in a way that we can make sure that we are reaching as many young girls as possible who are interested in getting into vector control, and matching them up with appropriate mentors that could help them build their career.
Okay.
Thank you, lots. And Damaris, I hope you're going to stay with us for longer, so we take another break in the middle, and then we can proceed with the person. Is that right?
Yeah, sure, Frederick, that's fine.
Yeah, and on the last point you guys were talking about, I think it's for us, I guess there's also a role for us, right? So, both as boys, but also as Ifakara Health Institute, we will try to create more of these opportunities. These masterclasses are 100% free of charge. Anybody can attend them, and we are very grateful to our experts who are willing to spend 150 minutes of their time, sometime more, to talk to pretty much everybody from the junior most to the senior most. So I truly appreciate it on that basis. If you guys don't mind, we're going to proceed with the technical discussions, and then we will finalize again with a little bit more personal discussions. That's okay. And kindly continue with the chat discussions. If somebody really wants to raise an issue, do let Sheila, myself, and Damaris know, and we will call you guys up to do that. Sheila, did you want to invite Ole first, or shall we proceed?
Yeah, let's invite Ole.
Yeah.
To
Ole, there's a petition in the
PBO.
chat to invite you. So there's a very strong petition to have Ole speak about the PBO nets. So please.
Okay, what do you want me to say?
Just your opinions about PBO availability, the concentration, whether concentration matters, how to test for this in operational
So I should say that I have worked on this subject for some years, and I'm about to publish it together with Sarah Moore from Ifakara. So since Ifakara people are here, like Fredros, he probably knows that. So what we do is we try to chemically measure surface insecticide on the surface of yarns, instead of relying only on bioassays. And we use different extraction methods, including soap washing, to see what does soap wash actually remove and what does it leave. And even a single soap wash does not remove all insecticide, so much I can say. But you can extract it, and you can compare, and you can see a part of the insecticide which is found on the surface is not bioavailable, or it's not active. It doesn't do anything. So you can have very different surface concentration measured chemically and have the same biological effect. So it's the conclusion of this study is that you can't just rely on one method to know what you're dealing with, because you also have technologies which bind the insecticide inside the yarn. And when you then measure the remaining insecticide with a chemical method which is extracted from the yarn, you get a nice dosage, but it has no effect because it will never surface. And therefore, what this article suggests is a combination of bioassays and chemical assays, which shows together what you're dealing with. Because right now you have a bioassay based on mortality and KDR, which goes into saturation because they can never exceed 100%. And you have chemical assays which do total measures, but it is, to be nice, irrelevant.
Thank you. Thank you so much. Thank you so much, Ole, for the additional comments.
But when Sarah has the time to finish the paper, I think it's a nice paper.
We're looking forward to that. Yeah, that would be great. All right, so we talked a lot about PBO nets, nets with synergies, but there's a different kind of net. This is nets with multiple actives, pyrethroids, and other things that are not PBO. And there's no one better to discuss this with us than Corine. Corine, you've written a lot on this subject. You've worked a lot on this. You've tested them. My favorite of your papers is this one from, I believe, 2016 on Olisep Duo.
Okay.
But there are many others that you've worked on. And we are requesting you to talk to us a little bit about the value of nets that have more than one active ingredient, and how that will play in the space where people are still even questioning what the additional value of PBO is. So first, why are we going after these nets? Two, how will they be rolled out alongside everything else? Very general opinions on this subject of other net types that are not PBO.
Yeah,
and if you don't mind, there's a third part of that question, which is we do notice that WHO PQ already has listed a number of these nets, except they're not listed as resistance busting nets. They are, but if you read the papers seem to suggest that the nets are being developed for resistance control, resistance busting. So can't you talk to us through this? And if anybody has comments on that as well, it would be nice to hear.
Yeah, thank you, Fedros. And I think one of the first dual active ingredient nets that came up were the PBO nets. Then the difference is that you have to depend on the PBO to have the effect. That's it's kind of a synergistic effect. But looking at dual active ingredients, you're taking advantage of the mode of actions of the two different insecticides that are put in the net. And right at the moment, we have nets that have pyrethroids and either pyriproxyfen or clofenac. And the advantage of having the pyrethroid on the net added to it, because there is pyrethroid resistance. So somebody may ask, but why are you adding a pyrethroid on the net when there is pyrethroid resistance? Pyrethroids have been for many years very useful insecticide on nets, and that's because they have this high rapid action effect, the excito-repellent effect, where it causes them to act rapidly on mosquitoes. And by that effect, they are able to reduce blood feeding. I mean, even data shows that you could have reduced blood feeding when mosquitoes are resistant, but it's usually not as low as if you used a net that didn't have a pyrethroid on it. So with Interceptor G2, for example, the nets that we tested, which were treated with clofenac alone, we were not able to achieve good levels of blood feeding inhibition. So there is an advantage to have these two active ingredients, that's adding the pyrethroid to this, until we have a new kind of insecticide that can do all of this, that can increase mortality and at the same time reduce blood feeding and maybe drop the pyrethroid. We can talk about single active ingredient nets. So most of these nets have shown from the studies we have done really high efficacy against pyrethroid resistant mosquitoes, wild mosquitoes in experimental health studies. I think that the challenge now would be to be able to assess these nets in a randomized control trials, which are ongoing. There's one ongoing in Tanzania and another one here in Benin. And we hope that the data would be able to show that these nets can actually provide an additional protective value compared to pyrethroid only nets. So as to how these nets should be rolled out, it depends. I think that where you have pyrethroid resistance and there is a possibility to have an improved effect if you use these nets. For example, if there is no resistance to clofenac or to pyriproxyfen, then you could use either Interceptor G2 or RoyalGuard against this vector population. But I think that we still need to wait for the data from the randomized control trials to be definitive on this issue. So these nets, as I know, have been listed by PQ, and this is based on data from experimental health studies, which have been done following WHO guidelines. And from my understanding, unless they have been created, as there is a new class that has been created and confirmed by the VCAC, that's GMP, then we can not really claim that these nets are able to protect against pyrethroid resistant mosquitoes, that they have an effect against resistant mosquitoes, even though the data from her trials do show that there is an impact against resistant mosquitoes. So it's an issue of about the guidance that is being led by WHO. And I don't think I'm in the best place to explain that. Maybe someone from WHO can explain why they are listed and they are not considered as resistance breaking nets. And
I saw that we have I noticed that we have Marion on the call actually. So I don't know if Marion is still there. Marion, are you still there?
Yes, I am, Frederick. Can you hear me?
Yes, we can hear you. Okay, so I think this is really in your wheelhouse.
Yes, there's been a lot actually that has been in our mandate today. It's very interesting. There's a long story here, so I'll be very brief. I think just a reminder to everyone that when PQ assumed responsibility for the evaluation of vector control products, the pre-qualification evaluation of vector control products, WPIs had been in place for many, many years. And that meant that when PQ sort of arrived, for want of a better word, there were actually two focus. There was one to continue on making sure that there were access to nets, because we could not leave the procurement agencies without enough product to provide to vulnerable populations. So a lot of the focus was on continuing to make sure that these nets were available. And of course, we very publicly said at the time that we would follow on and use the WPIs guidelines. So there was a large number of products that went through the transition process. And these were a couple of the products that actually did go through the transition progress and received a PQ listing. Not in isolation though, most certainly with our colleagues in GMP. And of course, there will be data, as you've talked about, coming in to further support the use of these products. But I would just encourage people, and we can take some questions offline or at another time, or even give you a masterclass if there's enough interest. That would be great. Yeah.
Fantastic, thank you.
Yeah, I would just say though, that if people read the decision documents, which I know are lengthy and they're long, but sometimes you may find interesting information in the efficacy portion, and that may not support fully what you think, but you will at least have an idea of the strains, both susceptible strains and resistant strains that the products were tested against. So, I mean, I could go on all day about that, and I won't, but that's just a bit of a tidbit, and I hope that answers the question. Thank you. Over.
Thank you so much. And for those who do not know who Marion is the head of the WHO PQ process. So you can answer all the other questions about how this process works. Thank you so much, Marion. Back to you, Corine and Hilary.
Yeah, I think I talked about the nets, and then for the IRS, we do have a few IRS insecticides coming up, which are already out there that we have tested. And we have a Fludora Fusion, and we have SumoShield, and also there is a new active ingredient that is under development. So I'm not sure if we have already data on the phase 3 effects of these IRIS products, which have been published yet, but I think that the evidence so far shows that they can be used against pyrethroid-resistant mosquitoes effectively in many communities. I think for the latest new product which is being evaluated, there are trials ongoing, and there should be data to support their use against pyrethroid-resistant mosquitoes.
Thank you. Thank you so much. And we would like to tie this in. Dear colleagues, if you're on the line, we kindly request you to mute your microphone if you're not speaking. Yeah. Sorry, Shayla, if I mute you by mistake. I was trying to mute the other guy, so kindly unmute yourself. Yes, Hilary, I hope you're still with us. We have a question for you here that is related to the earlier question. This is for a question to Professor Hilary. In 2016, you wrote this paper in the Lancet together with Professor Hemingway. And there is a statement in there that talks about new insecticides only being able to reach the market 5 years later. So here, this was 2016, and the warning that we were putting out there was, we will have new pesticide classes only 5 years from now. The question we have for you is, do you have any idea, and maybe our IVCC colleagues are here as well, how much progress have we made on that front today? Are we doing okay? It's been 5 years.
Yeah, and I don't know, because the last author on that article was Nick Heyman from IPCC. I don't know if there is anyone from IPCC on the call that could give an update, because I'm not fully up to date on this. I mean, we've had what's called repurposed insecticides that Corine has been talking about, chlorphenapir and pyriproxyfen, that are now available for use in vector control products. That they're not new insecticides, they've been used in agricultural pest control in other sectors before. But in terms of brand new insecticides, I'm not quite sure where we are up to. I'm afraid I'm not fully up to date on this, and I'm also not sure if what I do know I'm allowed to say. So I think I would. Do you have
anybody from IVCC, maybe? How are we doing with the insecticide business? Yeah? Anyone from IVCC?
Or any of the industry partners that are online?
Or the industry colleagues? All right. Okay. Let's hope there will be some progress on this. I think that's something that worries people a lot. Sheila, do you have any questions on that regard?
No questions, Fred. Thank you.
Okay. So why don't we proceed and talk a little bit about indoor residual spraying, and this is either yourself or Corine can respond to this. This is a publication from Miriano Joan Tangena, forgotten the first name. Dr. Tangena, this is a publication from, I believe, 2-3 years ago. She reviewed a lot of detail about indoor residual spraying, and you see two interesting pictures on this publication. First, you see the increase in number of countries and number of households. Dear friends, kindly mute yourselves, man. Or I will remove you from the call. You see two interesting trends here. The first is an increase in number of houses. Let's go on at the table there. She did a fantastic job just listing the options we have and against which ones we already have resistance. And as you can see, the only survivor there is clothianidin. So pretty much everything is on the way out. But here you see these two trends: increasing proportion of people being covered, increasing number of countries being covered. At the bottom right, you see this graph that suggests something very different. And that is the proportion of people protected remains flat. So we would have expected that as we have more people, more countries that, taking up indoor residual spraying, that the proportion of people protected would also go up. So we start to wonder, is this a question of people, of countries, more rationally using their resources, spreading too thin, saying we have only so much, and if so many countries are doing it, then we have to, we can protect only so few people? What is the reason for this, Hilary or Corine?
So maybe, I'll give my opinion, but Corine, please correct me. But I think what we saw was, as we had to phase out the use of pyrethroids for IRS and replace with alternative insecticides, which were much more expensive. And so although countries may have continued or even started new IRS programs, they are doing so with more expensive insecticides. And so the number of households that can be sprayed, if budgets remain the same, reduces. So I think it's a question of economics, but Corine may know better than I do on this.
Unfortunately, I don't really know much, but like you say, the switch to maybe carbamates, then organophosphates, and neonicotinoids, it's costly. So as control programs are switching to these more expensive insecticides, it may have had an impact on how many people they can actually protect with IRS. And also IRS is more of a focal intervention. It's not meant to be deployed everywhere. I don't think there is an advantage in just deploying IRS everywhere. It should be deployed strategically, making sure that you're applying it only in those areas where you really need to drive down transmission as much as possible, especially considering that most IRS will be deployed against a background of already high coverage with ITNs. So I would focus IRS only on those areas where I think that I really need to drive transmission down as much as possible. So the proportion of people covered would really not be the main point to evaluate here, but maybe the impact overall and things like that.
Thank you so much. Thanks. Shall I want to add? Brilliant. So I think we have a related question on that, which is based on a publication also from Imperial this time. The other one was from Liverpool, I believe. This is by Ellie Sharon Smith, and she's done a similar review on IRS, but she's presented a fairly interesting conclusion here, which is about the formulation time and how long it takes, how long these formulations last. The major argument here is that IRS formulations that last long are, more useful. But if you look at the specifications, and we could go back a little bit up here on the Julian's paper, the formulations that we have, the maximum here is really just 8 months, given DDT is no longer pre-qualified. So the economics and the feasibility of IRS, is this a weak point in terms of using indoor residual spraying as an intervention? Or if countries can't feasibly spray twice, and protection is not there?
I think that depends on the seasonality of malaria. So IRS is great for countries with very seasonal malaria that maybe only 4 months or so of peak transmission. But if you've got year-round transmission, no formulation is going to last that long, so you have to reapply, and then the economics start, they don't stack up really. So yeah, that's a really important thing to consider when looking at whether to use IRS is how long the transmission season is.
Two quick questions here for you, Hilary, and we're going to try and move quick towards a close. This is an interesting paper, and I actually think I saw Toy Hyacinth on the call. This is an analysis of resistance work you guys did in Burkina Faso. And you reported something here that was a little bit strange. You reported 1,000-fold resistance levels in insecticide resistance. This is from a while back, but I guess the question is, at those levels of resistance, do we really have any option? And by the way, is this widespread phenomenon, or it's just specific to Burkina?
So from my understanding, I think Burkina Faso and Côte d'Ivoire seem to be a hotspot of pyrethroid resistance. And certainly, and it may be that there are lots of entomologists in those two countries, so we've got lots more data, but the highest levels of pyrethroid resistance I've ever seen have come, well, in Anopheles gambiae, I guess there's Phonestus in Mozambique is incredibly resistant as well, but in Anopheles gambiae complex, they seem to be the most resistant populations. And but as to how resistant they are and whether this 1,000-fold resistance is really meaningful, I think it's something that we've struggled a lot with in our group, is trying to think about what's the most meaningful way of measuring the intensity of resistance. So I think, and Toei, I think he's on the call, so he can correct me if I'm wrong, I think this was a dose response curve from CDC bottle bioassays that we came to this conclusion from. In other studies, we've looked at the time it takes to kill and looking at LT LT50s and LT90s. But when you get to very high concentrations of insecticides, you're sort of reaching a plateau effect. Either you can't physically get enough insecticide into solution to do the bioassays, or it's not stable. So yes, I mean, this assay, this population, this was from Vallée de Cou, I think, in Western Burkina Faso, showed 1,000-fold resistance. Others in Côte d'Ivoire, I think I've seen things that have been 2,500-fold. But I think there becomes a point when basically they are so resistant that whether it's 1,000, 2,000 or 10,000 perhaps doesn't really matter. And I don't think there's consensus about what the best way of quantifying resistance is yet.
There is a related paper that you guys read with this. You have these 2 publications, very interesting. The first one is with Diana Mafalda and yourself from Glasgow. A great demonstration there of how sublethal impacts can ensure that bed nets continue to work. But this is with laboratory data. And then you go to Burkina Faso, and you go to the field, and you check whether these sublethal effects actually are real, and you see none of it.
Yeah.
What does this? I can see you're breathing.
Yeah.
Like really worrying.
So my interpretation of this data, and it's that so we do see sublethal effects from insecticide exposure, and I think this is a really important thing to remember. We talked earlier about what's the most useful entomological indicators to use, and typically with bioassays, we've been looking at, with pyrethroids, we've been looking at 24-hour mortality. But of course, what really matters is, do they live long enough to transmit the parasite? So this first study here on the left was looking at that, looking at what the impact of pyrethroid exposure is on the whole lifespan of mosquito populations. And this was looking at 3, I think, or 2 or 3 different laboratory colonies that we had at the time that varied in their 2 populations, Tiasley from Côte d'Ivoire and Touro from Uganda, that varied in the strength of resistance in its populations. And we found that although both populations were defined as resistant by 24-hour mortality assays, they both had reduced lifespan after pyrethroid exposure. So if you expose them to a pyrethroid treated net, they didn't live as long as if you exposed them to an untreated net. So that was quite encouraging, because it sort of said, well, okay, they are resistant, but probably even in the field, they're not going to, even after pyrethroid exposure, they're not going to live long enough to transmit the parasite. They might live, to the next day or 2 or 3 days longer, but they have been impacted by the exposure. But yes, then we went to Burkina Faso a few years later and did this we repeated the experiment exactly the same with the laboratory assays, but we also had the opportunity to look at mosquitoes that have been exposed to nets in experimental hut studies, and look to see if you had an untreated net or a pyrethroid net in the huts, and then you took the mosquitoes out the next day and you kept them until every last one had died. And you can see in this figure at the bottom here, either of these figures, it's one just showing that there's actually no difference in longevity of the mosquitoes depending on whether they've been exposed to untreated or pyrethroid treated nets. So again, in this area, which is one of the most resistant populations that I know of, pyrethroid exposure here had absolutely no impact on the mosquitoes. They just didn't die. They didn't die immediately, but they didn't die 5, 10 days, 15 days later. They just behaved exactly as if they'd been exposed to an untreated net. So my worry is that we're going to see more populations like we see in Burkina Faso, but it's possible that there is something strange about that population. And there's lots of indications from other studies that we're looking at with some of these new classes of nets that Corine was describing. They seem to be performing differently in this populations of Burkina Faso than we see in other parts of Africa. So is that because the pyrethroid resistance is so strong, or are we dealing with something a bit different in this setting? But I would encourage people to do studies looking at the lifelong, looking at longevity for the whole lifespan of the mosquitoes after exposure, just to see what you see in your settings. Because if it's like the first study we did, that's quite encouraging. If it's like the second one in the field, that's very concerning.
Yeah, thank you so much. We're going to review questions. If you can bear with us 30 seconds, Sheila and myself will review just to check which questions we still have to left. So Sheila, just put up the slides there. Some of the important questions we don't want to miss. So Sheila, if there's any of there that we think we're still missing, we can take that up, given the time is running out. Otherwise, for all our colleagues joining, please stay with us. We're almost completing. We just want to make sure that the important questions are all covered. Sheila, are we good?
Yeah, so we have a couple of questions that we haven't touched on. So one is on how do entomological parameters change, like feeding inhibition, deterrence, repellency, with changing or with various intensities of insecticide resistance across the different mosquito populations and across the lifespan of a specific product.
Yeah.
So do we see changes where there's insecticide resistance? Because insecticide resistance only looks at mortality. So when we look at these other indicators, how does this change?
Yeah. And we just pasted a slide there on longevity of nets. There'll be additional questions of that. That's mostly on durability. But I think what Sheila is asking more bioactivity. So we can start with that. Thanks, Sheila.
Corine, do you want to answer, or do you want
I think Hilary, you can go ahead.
Okay, this is a difficult one. Yeah, it is a really good question. I mean, I think the impact of resistance on mosquito behavior is something that there's lots of work going on at the moment, but lots of gaps in our understanding of this, and some interesting observations that comes from the meta-analysis that the Imperial group have been doing, combining data from multiple studies from across Africa and looking at populations with different levels of resistance, and finding that the degree of deterrence or exophily or blood feeding inhibition does seem to be correlated with the levels of pyrethroid resistance. But because many of these factors there'll be some confounding factors, because there'll be linkages between these different factors, because a mosquito can only behave in a certain number of ways. If it doesn't enter the hut, it can't blood feed, for example, it won't be killed. So actually interpreting this data is quite complicated, and that sounds like a bit of a fudge, and it is really, because I think at the moment I certainly don't really understand enough about how pyrethroid resistant mosquitoes behave in response to the nets. But this is work that Philip McCall and Geraldine Foster and others have got some projects that they're leading here to try and look at how mosquito behavior, how resistance impacts mosquito behavior. And we're working with groups, with colleagues in Burkina and Benin and Tanzania and elsewhere, trying to look at this under field settings. And I hope that in the next year or two we'll understand this in a lot more detail. But at the moment it's murky and difficult to interpret these results, I think. But maybe Corine has a simpler explanation. I'm not sure.
Yeah, I think you talked about the Imperial study, which is ongoing, and I think that has been a useful study. But I think one of the major issues has been the fact that most herd studies are done alongside resistance data that is done with a diagnostic dose, a single dose. So it will be useful for most people doing herd studies to be able to generate data on intensity of resistance, so that that kind of link can be properly made, and that could be a better indicator to use to be able to compare the levels of control and the different parameters with the levels of resistance in different vector populations. So at the moment, I really don't have a major point to say about that. Maybe when the Imperial paper is out, that could explain more.
Yeah, thanks both. I'm looking forward to that specific study to gain more information and more knowledge about this specific topic. So in relation to testing efficacy of residual efficacy of IRS and durability of bed nets, looking at the insecticidal activity, the main indicator there or parameter there is that nets are considered effective if they are killing more than 80% of the mosquitoes. So does this also apply in low transmission areas where mosquito densities are really, really very low? How should we be looking at this? Is it fair to be using the same parameters in high transmission areas to determine efficacy in low transmission areas?
I'm not sure if I really understand the question very well. If you want to...
Yeah, so I'll try and yeah. So when we are testing residual efficacy using corn assays, we consider insecticides that are killing more than 80% of the mosquitoes that are being tested. We consider those to be effective over a period of time. And we do the same for bed nets. So if we go out at 6 months after we have distributed the bed nets and we conduct our corn assays using susceptibility mosquitoes and we see 80%, we will consider that net to be effective. But as time goes by, when mortality reduces to less than 80%, then that net is not considered effective according to the WHO guidelines. So my question is, using these parameters in the low transmission areas where mosquito densities are very low, using the 80% threshold, is that fair, given that our interest is in reducing mosquito densities by killing them? Should we reduce the threshold?
Yeah, I'm not sure what the answer to that question is, because if we are looking at efficacy, we want to measure against using a really controlled system. So if we bring a net from the field, we need to have a threshold that we can use to monitor the efficacy of these nets. And as long as we are using laboratory maintained mosquito strains, if we have a universal threshold, I think that should be acceptable across all settings. Where there is issues of low transmission or low mosquito density and all of that, is when we want to evaluate these products against the wild population, maybe look at the impact on vector density. That is when we could factor in the issue of low transmission or low density against high density. But if it's just about efficacy, I think that defining a universal threshold is absolutely important. Maybe Hilary has something to say about that.
No, fully agree.
Mm-hmm.
Thank you. Thank you so much. Thanks. You continue, Sheila? That's it?
So this is a separate question in relation to durability of or insecticidal activity of nets. So sometimes you notice, and given the example on the screen now, sometimes you notice that when you're testing these bed nets, sometimes you note that mortality reduces and then increases at some point. So is this related to the way the insecticides are incorporated into the fabric? What's your opinion there? What is happening there?
Yeah, if I can answer this one, because it's from one of our papers. The day zero there, where you have the dip at day zero in knockdown and mortality, it's the day on which the nets were washed and tested. These are results from regeneration time studies, where a net is washed 3 times and then tested over successive days, that's up to day 7, to assess at what point we start to get mortality again. So the day zero is the day on which the net is washed. So we decided to test that net on the same day it was washed. And it wouldn't make sense that you have that dip in efficacy on that day zero. But the data here is showing that by the time you leave the net for 1 day, you return back to the same level of mortality that you had when the net was unwashed. And for the reproductive effects on this graph as well, we did notice that it required up to about 3 to 5 days before we could start to get a plateau or a similar effect as we had when the net was unwashed. So it's not really about this variation, but it's more about how the testing was done on the purpose of the testing, which is to see at what day, how many days after washing that we get an impact again as similar to what we had when the net was unwashed or when it reaches a plateau.
Yeah, thanks, Corine, for clarifying that. Back to you.
Thank you. Thank you so much. I think from my end, there's only two final questions, and then we will, Sheila will complete, and we will invite Damaris to finalize this. And I'm going to show you 3 slides and then seek your ask the question, if you don't mind. The first one is this one, and I think, Hilary, you mentioned the work that Philip is doing. He did appear in one of the masterclasses recently and talked briefly about that specific concept of using barrier nets, which we think is, a great innovation given the mosquito behavior. The second one is the work by Dr. Flaminia Katerusha from Harvard, essentially putting medicines on bed nets and getting bed nets to take a dose of medicine. Flaminia was speaking at the Women Malaria Conference recently, so many people might have seen this also, and she's spoken about it previously in other conferences. The third slide is about Eve tubes. High doses of alpha-cyflothrin on the small pots, demonstrating great power in not just entomological efficacy, but also epidemiological benefit. All these are innovations that are aimed at improving the power of the insecticide, the tools that we have, and the power of the bed nets that we do that. Very generally, we would like to hear from the two of you as experts. What are your views on approaches such as this, and how much potential do they have? And also, what do we need to do as a society to encourage this kind of innovation to ensure that we can sustain the power of the interventions that we have going forward? This, I guess, is a very general question, so you can take it whichever direction.
Maybe I'll start by very briefly. I would say I think all 3 are very exciting. I think they've all got potential. They are at different stages along the sort of pipeline. Perhaps the Eve's tubes is the closest to something that we may have some policy recommendation on soon, because a second trial is hopefully going to start shortly. The barrier bed nets, there's some questions about whether they would fit with an existing product class that would need to be addressed. The drugs, I think, is a really interesting idea. And as Flaminia was talking about last week, they're looking at alternatives to the drug used in this assay, which was tovaquone, so they can find alternatives that aren't currently used in malaria control. But that would need full clinical trials to see how impactful it was. But I think they're all very exciting.
Thank you. Corine?
I haven't read much about the barrier bed nets, but about the Eve tubes, I think the data did show that they could really have an impact. And I think the challenge here would be maybe the cost and the acceptability of these interventions. It showed to be really cost effective in Cote d'Ivoire, but how about other settings? Is it really scalable and all of that? So these are questions that we need to answer, not just in the trial that was done in Cote d'Ivoire, but we will need maybe data from trials in another area to fully assess the impact, the epidemiological impact, acceptability, and cost effectiveness of this intervention.
Thank you. Very short answers from your end on the following as well as we draw towards the close. Durability. Should we or should we not worry about it?
absolutely we should worry about it. I think some of the recent findings are very alarming, and much, I think this is a really, really urgent question that needs to be addressed. Why are some of these products lasting such little time under operational conditions, and why is it seemingly much worse now than it was when some of the earlier durability studies were done, when the nets were long-lasting insecticide nets were first introduced? So really urgent area of study, I think.
Corine, you had a conversation with Lena before the call. How is this going? Maybe Lena is on the call.
Yeah, I was hoping that. I was hoping that she'll be here to talk more. Can you hear me?
Yeah, now I can hear you.
Yeah, I was hoping that Lena would be on the call to talk more about the functional survival of these nets. But I do agree with Hilary. I think that it's becoming really more important because, I mean, you can distribute nets as you want. You can make sure they are as effective as you want. But if people don't use the nets, especially when the nets are lost to attrition, then I think that there is really a major issue there, and we are failing, and there is a reason to monitor this as much as possible. So it's more about the manufacturing industries to do the best they can to manufacture nets that are as durable as possible.
Thank you so much. Sheila, you wanted to make a comment on that?
No, thanks. Thank you, Fred.
Okay. Brilliant. So we're going to invite, here is a provocative question. Hilary, do you agree or do you not agree with this image?
So, as I said at the beginning, I don't think that these tools combined are sufficient to eliminate malaria from Africa. But I do think that they can't be discounted. They're the best we have at the moment, and they shouldn't be discounted. But if the question is, will they ever be able to turn around the ship? They have. I mean, we mustn't forget the success that we've seen since the year 2000 with malaria reduction, and largely been due to these tools. But as I said, I think getting down from very high levels to lower levels is the easy bit. Getting down from moderate levels to elimination is going to be much, much harder. And I don't think that it can be done with these tools alone, but I wouldn't throw them out. I think we're going to still need them for the foreseeable future.
It'd be nice to hear from the audience. If anybody has any comments, you can just type agree or I don't agree. Let's see how that goes. Whichever direction you interpret this. Damaris, are you with us? Can you come back on and have the last questions before we close? I don't know if Damaris is still with us.
Yes, I'm here. I'm here.
Yeah. We have the last 5 minutes for you.
Yeah, thanks. I have a quick one for our speakers. And one of the things my thoughts are in is how is the investment or donor funding or investment towards malaria should be geared. And my thinking is more, should it look at gender as one of the criteria of awarding? Do you think gender plays a role in the funding? Do they need? How should the policies be that they should also look at gender diversity or inclusion in funding for malaria control? And also, the other thing I like speakers to comment about is the policies that we have in place. One of the things that we have had an issue within, and we have been trying to see how to address in PAMCA, is issues to do with sexual harassment, bullying, etc. So how do you think policies are there in place at global levels that address gender and sexual harassment or bullying? So those are the two questions. Funding, should it look at gender inclusivity, and also policies towards sexual harassment and bullying? Thank you.
Thank you, Damaris. Shell, I think you can answer as well here. The question is for Hilary and Corine, but I guess you are a respondent to this as well.
Okay, I'll briefly say something, but I'll hand over to Sheila and Corine. But in terms of funding, yes, I absolutely think that funders should be addressing this. I think one thing that is often very neglected and difficult to get funding for is strengthening. So funding for capacity strengthening is often directed at individuals, but not at institutes, and creating stable career pathways and building strong research institutes that have all the necessary elements for researchers to thrive. And I'm not aware of any funding that's been looked at that with a gender lens on, to say what do we need to do to improve this institute to make it more equitable for women in areas where women are underrepresented, or men in areas where they're underrepresented. And I think that could be hugely transformative if funders did that through the institutions, as well as looking at personal funding and fellowships, etc. And harassment policies and bullying, policies around bullying and harassment. I mean, I think people should not be able to receive funding unless those were not just in place, but actually adhered to as well.
Corine and Sheila?
Yeah, if I could add to that, I do think that there is, to some extent, there is usually some consideration with some funders where they try as much as possible to include gender in their kind of requirements and eligibility or things like that. And I think that there is more to be done about that. There are quite a lot of funding calls that do not really clearly address gender. So I think that more consideration should be given to gender when it comes to funding, and also should be given to carrying people's career to the highest levels that they can achieve, not just funding considering gender at a lower level, but also looking at how the women can be supported to really reach high levels in their career. And I think that sexual harassment, bullying, and all of that should really not be tolerated in a milieu of research, not only for vector control, but for everything. And it's up to everyone to try to speak up whenever you see situations where there is sexual harassment and bullying. Even the men should be included in speaking up about things like this. Thank you.
Thank you.
Yeah, thanks. So I think women have been included at some level when it comes to donor funding. There are some donors who actually take into account the women of childbearing age. They actually take into consideration the years that women take to stay at home and look after their children or look after their families. So I think something is being done, but it's not enough. I think more needs to be done. Yeah.
Thank you guys so much, and thanks Damaris for your time as well. I would like us to draw this to a close, and as you can see, where were we? I'm trying to find our last slide. Yeah. So I would like to draw this to a close and really just say thank you so much, Hilary, and thank you so much, Damaris. Thanks, Sheila, and thanks also to Corine. Before we close this chapter, I would like to ask Corine and Hilary if they have any words for our young people on the call and those who attended this event, and also if they have any words for us on how we can improve the masterclasses going forward. But first, really just to say thank you so much for taking the time to speak with us today. for being vulnerable and standing up without knowing which questions we will ask you, but still making time to do this. Corine, it was fantastic listening to you, having this detailed conversation with you. Hilary, we have dreamt of this for many, many years, and it was great that finally we were able to do this. Sheila and myself are very appreciative, but I'm sure the people on the call are equally more or even more appreciative. So if you have any final words, we can start with Hilary and then Corine.
Well, thank you both for organising this. It's been really interesting, and I'm going to go back to the YouTube channel now that I know it's online and look at some of the ones I've missed. So thank you for that. And just in terms of words of advice or encouragement, I think some of the topics we've discussed today hopefully highlights that there's so many questions that are unanswered. There's so much to do in this field, and we desperately need more young scientists to work in vector control and vector biology, and just encourage people not to give up. It's a fascinating field and fantastic people working in it. So don't give up, I think.
So, for me, I really want to thank you, Fedros and Sheila, for inviting me to be a speaker here, and I appreciate it. And I have benefited in my career from watching many people, and I think one of them has been Hilary. So I thank you so much for being on this call as well with me. And for the younger people coming up, I think that there is a place. There is a lot to be done in vector control, and there is no need to be discouraged. I think that people who are looking for careers, I hope that the discussions have raised questions and ideas on different types of research that can be done to further answer the questions that we have at hand. Thank you.
Thank you. Thank you so much, and thanks also to my excellent co-host, Sheila Ugoma. If you guys allow me, please give a warm round of applause for our colleagues. And thanks also to Damaris for joining us today as a co-host, as a guest co-host. This was really, really helpful. Thank you so much for that. We are going to close this now. And until, like I mentioned earlier, our next masterclass is scheduled for April 8th. It will be delivered by Professor Pedro Alonso, Professor Patrick Kashur, and Dr. Elizabeth Juma from WHO Afro. You're warmly welcome. Please wait for the invitation. You will receive this either through BCWG, Malaria World, or Twitter. And we are grateful for all our partners who help us spread this message. On behalf of my colleagues at Ifakara Health Institute, and on behalf of myself and Sheila Ugoma, I would like to return this to Sheila to close the meeting. Thank you very, very much. Sheila, please.
Yeah, thank you, Fred. I'd like to thank all the participants for joining in and for staying with us, and for keeping the chat box really lively and asking important questions. We already have ideas of our next masterclass. And a big thank you to Corine and Hilary. Thank you very much for the really useful discussions and for your time. Yeah, thank you very much. Until next time.
Goodbye.
Goodbye, everyone.
Bye.
Bye-bye. Thank you, Damaris. Bye-bye. Sheila, we have a debrief. Either we do that on a call, or right? Yes, we can do that.
Let's do that on a separate call.
Yeah.
Yeah. Okay.
I'm just gonna close this now.